Hi kids, and welcome back to graphing. So year 10s, we've already done the revision exercise last lesson, which was drawing straight line graphs or finding the equations. This one is finding the equation of a line, exercise 1G. So you can copy the notes down, and we'll stop there. And I'll explain it. I might just let you copy all the notes down at the end once I've filled in bits and pieces on the board. So, the first thing to remember up here, y equals mx plus c. The value m stands for the gradient. You've got to remember that. And the value c stands for the y-intercept. So hopefully you remember that from year 9. The next thing we have to remember, m is the gradient. The formula for the gradient is rise over run. So if you've got a diagram, a graph, you can draw your little triangle in and work out rise over run. Remember whether it's positive or negative as well. And if you don't want to use that and you've just got two different points, you can use the formula y2 minus y1 over x2 minus x1, and that will work out the gradient for you, and it'll put a positive or negative in front of it automatically. If you've forgotten that, I'll be doing it in a second in an example. Alright. Another thing to remember, gradients, positive gradient goes that way, negative gradient. A zero gradient has no slope because the gradient is the slope of a line. And if it's a vertical line, it's got an infinite gradient, or sometimes we call it undefined, so either's fine. Okay, so hopefully you remember all that. Little warm-up activity. Find the gradient of this line, this graph. So, as you notice, the one point goes through the origin, and the other point is here at 2, 6. We can see that. So what we need to do is get our texture out and draw in our little triangle between those 2 points. So we draw our triangle in. This section here is the rise. The rise goes from 0 to 6. So the rise is 6, and the run goes from 0 to 2. So the run is 2. That distance is 2, that distance is 6. Now we can work out the gradient is rise over run, which is 6 over 2, which simplifies to 3. Before we move on, and you have to remember that is in the positive direction, so we leave it as plus 3. If it was sloping down the other way, just work out the 2 numbers, and then at the end put a negative in front of it, because it'd be a negative slope. Alrighty, now we're getting on to the meat of this lesson. Find the equation. Here we've got a graph. We need, for any of these exercises, all you need are 2 values. We need to find the value of m, the gradient, and find the value of c, which is the y-intercept. Alrighty, if you have a look at our graph here, we see it goes through the y-axis at 1. That is called the y-intercept. So we already have the value of c. So that's half our problem done. So we can straight away write c equals 1. That is our y-intercept. Good job, guys, we're halfway there. Alright, now we just need to find the gradient. Let's do the gradient. How do we do it? We have 2 points. We can draw in our little triangle, just like we did a second ago. So the run goes from 0 to 4. So the run is equal to 4. The rise goes from 1, see there 1, all the way up to 13. So 1 to 13, the rise is 12. So we can work out our gradient is rise over run, which is 12 over 4, and simplifies to 3, and it's in the positive direction. So we've done all the work. That was hard, wasn't it? That was sarcasm, but anyway. So we've got our c value, we've got our m value, so now we can throw it into our formula. Y equals mx plus c. So y equals, the value of m is 3, so it's 3x, plus the value of c is 1. And there's our equation, y equals 3x plus 1. Excellent. Let's move on to our next example, everyone. So here we can see we've got a line sloping this way. Please note, you can note it's a negative gradient, so we'll keep that in mind. We can see our y-intercept's at 2, so let's write that down. C is equal to 2. Now again, we need to find our gradient. Let's put our little triangle in. Triangle between our 2 points. So the run is, so this point is minus 4, so that point's there minus 4, and this point here is 10. You can fill that in if you want. So it goes from 0 to minus 4. Don't worry about the positives, the distance is just 4. Okay, and the rise goes from 2 all the way up to 10. So the rise is 2 to 10, which is 8. Can you see that? 2 up to 10 is a difference of 8. So that distance is 8. So now when we work out our gradient, it's rise over run. The rise is 8. The run is 4. So our answer is 2. But remember, our gradient is sloping in the negative direction, so we put a negative there. I find it's easier, rather than mucking around with 0 and this run is negative 4, whatever, keep them both positive. Just remember at the end that overall the gradient is negative. So now we've got our two values, y equals mx plus c. Y equals minus 2x plus 2. And there's our equation. We have finished. Excellent. Okay guys, so this is a second type of question you're probably going to get in this exercise. So the first type, remember, we had the y-intercept. It was given because the line went through the y-axis, so we had the y-intercept given. This time we have neither. So remember, there's two things we need to find, the gradient and the y-intercept. In this case, if you have a look here, we've got only a section of line. So what we need to do is firstly find the gradient, like we've done in the past. So let's draw our triangle in like that. We've got, should be good at this by now. We've got the run is from 3 there to 5, so the run is 2. Can you see it's a difference in the x values? And then the rise goes from 2 up to 6, so the rise is 4. Can you see that? They're the difference in the y values as the rise. So over here, let's work out the gradient. So the gradient is m. So it's rise over run. I'll just write that to remind you. So the rise is 4 over the run, which is 2. And that simplifies to 2. But what do you remember, everyone? It's sloping in the negative direction. So make sure you put the negative there. Good job, guys. We worked out the gradient. The gradient's negative 2. Now we've got something a little bit trickier. We need to work out what the y-intercept is. There's a new formula that you can use. So watch here, everyone. Y minus y1 equals mx minus x1. Okay, so that's a formula we're going to be using, and all you have to do is substitute the known values in. So we have to substitute, we've got the m value up there, so that's going to go into there, and this x1 and y1, they're the values. We can pick either of these 2 points. So I'm just going to pick 3, 6. So I'm going to call that x1 and y1. Just means it's the x value and the y value, and we'll call it 0.1. So I'm just going to write it down here. So there's our m value, and x1 is 3, and y1 is 6. Can you see that? I've picked it from that point. There's the x1 and there's the y1. So what we need to do is substitute these 3 values into this equation. Okay, so we've got y minus y1, which is 6, equals m, which is minus 2, x minus x1, which is 3. So I'll stop there. You notice that the y and the x, the normal y and x, they do not get substituted in. They're in the actual equation. The other values that we substitute in are m, y1 and x1. You got that, everyone? So we substitute those values in, and here's what we've got. Now we have to solve this equation. So the first step is we expand the brackets. Hopefully you remember how to do that. Multiply that, multiply that. So we get minus 2x, minus 2 times minus 3 is plus 6. Good job, everyone. And then last step is to add 6 to both sides, because we're going to get y by itself. Y equals minus 2x, 6 plus 6 is 12. And there you have it, everyone. We've got y, we've made y the subject, so it's in the form of y equals mx plus c. And there's our equation. I'll put a little box around it. You can check. The gradient is minus 2, and that's correct, we worked that out. And if you look here, the y-intercept is 12. We don't know exactly from this graph, but it looks like a sensible answer, doesn't it? Because it's up there somewhere, so our y-intercept is 12. So we've just finished it. Good job, guys. We're going to do one more exactly like that, but sometimes you might get the gradient is not a nice number like that. We just have to deal with it if it's a fraction. Hopefully in a test you won't get that. I can't say for sure, but let's work it out anyway. So same question. Let's work it out first. Let's use the gradient. So the run Goes from 4 to 8, so that's 4. The rise is 2 to 7, which is 5. So this gradient is not a nice number. So we've got the gradient is rise over run, so it's 5 over 4, but it's in the negative direction, so it's negative 5/4. Leave it like that, do not change it to a mixed number. Alright, we're going to use one point up there. I'm going to use 4, 7, and I'm going to label it x1 and y1. Because you can pick either of those values, I'm just going to pick the lowest value, it's nice and easy. Now we use our formula again. Y minus y1 equals mx minus x1. You've got to try and remember that formula. If not, write it down lots and it'll sink into your brain. Okay, so now we have to substitute those values in, these three values that we've got up there. So y minus y1, y1's 7, equals m minus 5/4, and then x minus x1, which is 4. I'll let that sink in for a second. So we substituted x1, y1 and the value of m into that equation. Now we do the same two steps. We expand the brackets and then we add 7 to both sides to get y by itself. So y minus 7 equals minus 5 over 4x. Now we have to multiply these two together. We know it's going to be a positive, and when you multiply, I'll just do it over here for you if you want. 5/4 times 4, which is 4 over 1. The 4's cancel, and it leaves us with 5. So that's year 7 fractions. Hopefully you remember that. So I'm just going to write down there 5, because we worked it out. Alrighty, now we plus 7 to both sides, and we get minus 5/4 x, and 5 plus 7 is 12. Good answer. And there's our answer. We can check our answer. The gradient is minus 5 over 4, which we worked out already. And again, this time the y-intercept is at 12, which is a sensible answer because it goes up there. So if you do get a fraction like that, a yucky fraction, you just have to deal with it. Hopefully you remember how to do it. You can do your workings over off the side like I did. But like I said, hopefully in a test you'll get nice numbers, like the first example we just did, but I can't guarantee it. Alright, over here is your homework that you're supposed to do for exercise 1G, according to the course outline. And if you just want to, we'll quickly go over the examples, so make sure you copy them down, and also the other work that we did. So make sure you pause the tape if you need to, copy it down. And good job guys, I'll see you for the next exercise. Bye.